Hi there, I'm Stuart Harrington, and welcome to the Essentials of Algebra 1. This is Module 2 of this series, and today we're going to be working on solving linear equations of one variable. These problems are going to be similar to things you started working back in 7th and perhaps 8th grade as well. But we're going to be stepping up the difficulty just a little bit because now we are talking about Algebra 1. So let's get started. As I mentioned before, previously in 7th and 8th grade, you began working on solving equations with one variable. Your teachers called them at that time one-step equations or two-step equations. And you used things like addition and subtraction and multiplication and division to solve those kinds of problems to get the x all by itself. And that is going to be the goal again today, to get the x all by itself so we can figure out what the variable is. It won't necessarily always be an x. It'll be an a or a b or whatever. But the idea is get the variable all by itself. If you take a look at your objectives here, we're going to be using those properties of equality, which means you have to, if you do something to one side of the equation, you've got to do the exact same thing to the opposite side. You're accustomed to doing those kinds of things. The other piece of this is not going to be one-step or two-step equations. These are going to be multi-step equations. We're going to have to do several things. We're going to have to do things on the left side. We're going to have to do things on the right side. Don't worry about, oh, that sounds so difficult, because I'm going to give you a step-by-step recipe for these problems that if you will just follow that recipe, you will have no problem in solving the equations, getting the answer that you need. Let's take a look at that recipe right now. Take a look at this particular problem right here. This is what we would call a two-step equation. You solved countless problems like this when you were in the 8th grade. Now let's take a look at how we want to solve this using the recipe. Look at this step right here. This step says to isolate the variable on the left side. That was your goal back in 8th grade. That means we want to get the x all by itself. And we're going to use our addition, subtraction, multiplication, and division to get rid of everything that is with that variable. So if I look at this particular problem, I've got a 7 over here that's with the x. I've got this plus 2, and I've got to get rid of both of those. We've got the 2 that's being added, and you'll remember that you'll always want to add or subtract something first. So we're going to get rid of this 2. We're going to work our problem by taking a minus 2 on both sides. That will leave us with 7x on the left-hand side, and on the right-hand side we've got a negative 47 and a negative 2. That's going to be a negative 49. Now how are we going to finish this off? We've got to get rid of that 7. The 7 is being multiplied. The opposite operation is going to be division. So we're going to come back in and divide both sides by 7. And we all know that 49 divided by 7 is going to be 7. So our final answer is going to be x equals negative 7, because negative 49 divided by a positive 7 is a negative 7. So once again, those integer rules that we talked about in Module 1 coming back again. If you're not solid with those, please continue to practice on those questions. On this particular example, we are looking at some ways to isolate the variable on the left-hand side and to get our solution. And how do we know that we're done? We know that we're done because we have a variable equal to a number. Those are the final 2 steps. You've already done those, many of those problems. So let's take a look at a second problem. 4m minus m equals 27. You'll remember we talked about in Module 1, if there's no number in front of a variable, we know that there is an understood 1 in front of that. If I look at this, this is no longer a two-step equation. We've got to do some more to this. So that recipe that we're looking at right here on the screen of just isolating the variable on the left side, we can't do that because we've got the variable in two places. We're going to have to add something to our list that we've always had. So take a look at step 1 of this recipe that I'm cooking up for you. The step says simplify the left side completely. Yes, that's what we did in Module 1. Combining like terms. That's what simplification means. We've got to get all of the like terms together. In this problem, there are just some m's to combine. There could be numbers there as well. You could have a 6 and then a positive 7 that we would have to combine into 13. But regardless of what happens, you have to simplify the left side. So we've got 4m minus 1m. That's going to leave me with 3m equal to 27. And then we're going to divide both sides by 3 because now we're back down here to isolating the variable again. We've got to get that variable all by itself. So we do that by division, and we get that m is equal to 9. So this problem, we had to add something to the recipe to get it to work. Okay, so let's take a look at another one. Let's zoom in on this thing just a little bit so that we can see a little bit better. We've got an a on both sides of the equation. You may not remember seeing that before. In fact, you may never have. But we can still solve this problem if we add something to our recipe. There's nothing to simplify on the left side. That's step 1. All right. There's nothing to simplify anywhere. So we've just got to go straight to isolate the variable. Well, we can't isolate the variable yet because the variable's in two different places. So we need to add something to our recipe. And that recipe step is going to be this guy right here. What happens if you have an x term on the right? You got to get rid of it. You got to move it over off of the right-hand side. Because remember, look what our final answer says. Our final answer is we have the variable equal to a number. So we want that variable on the left side, not on the right-hand side. How are we going to get rid of 3a? We're going to get rid of 3a just by subtracting it. I mean, it almost sounds too easy to be true. If we've got 3a, we're just going to minus 3a and it'll be gone. Okay? That's pretty awesome. Now you got to remember, if it's minus 3a on the right, we got to go minus 3a on the left as well. Now, we do have some work we have left to do because look at what's happened. The 3a minus 3a, that's gone, but we still have 10 over here on the right. Not a problem. But what about the left-hand side? All of a sudden, we got to go back up to number 1 here. Look at number 1. Simplify the left. Well, I've got 5a minus 3a minus 4. 5a minus 3a, this is not going to be too difficult. That's going to be 2a minus 4. And now we're ready for our fourth step right here to isolate the variable on the left side. You know how to do this just as well as I do. We're going to add 4 to both sides. That's going to leave us with 2a equal to 14. And then we're going to divide both sides by 2. And that's going to leave me with a equal to 7. And so that problem is done. All we had to do was sort of add another step to our recipe right here. We've got simplify on the left, simplify the left side completely. If we've got an x or a variable on the right-hand side, we need to get it off of there. Normally, addition or subtraction will take care of that without any problem. Isolate the variable. We know how to do that, getting our final answer, so we're good. Let's move on to another problem. Take a look at this one. This is very similar to the one we just did. If we follow our recipe, we'll be fine. First step says to simplify the left side completely. There's nothing to simplify there. All the like terms are combined. Is there a variable term on the right? Yes, there is. There is a b on the right-hand side. In fact, there are 6 of them. There are 6 b's over there. How are we going to get rid of those? The same way we did previously, using addition or subtraction. And so in this particular case, there are 6 b's. We want to subtract 6b. If I do it on the right-hand side, must do it over here on the left. Look how I write it underneath the term that's got the variable in it on the left side as well. That helps me keep things lined up and I don't get mixed up. So on the left-hand side now, we're going to have 3b minus 6b. That's going to be a total of negative 3b. We've got the minus 3 still hanging out. And over here on the right-hand side, we've got 15 hanging in there as well. We need to isolate that variable. We're going to add 3 because that's the opposite of minus 3. We're going to do that to both sides. And that's going to leave us with negative 3b equal to 18. Now we've got to get the b all alone. It's being multiplied by negative 3, so we're going to divide by negative 3. Got that just like so. The negative 3's divide out, which is what we want them to do, and we're being left with b equals negative 6. And so that right there is our final answer. We've got a variable equal to a number. Okay? A couple of problems like that, you should start to feel comfortable with that. So let's ramp up the challenge just a little bit more. Take a look at this problem. There are several things going on here. What do you see? What we've seen before, we've got variables on both sides of the equal sign, but then we've got a second variable sitting there on the left-hand side as well. That means we're going to have to implement step 1 of our recipe. Again, we haven't had to use it in a couple of problems, but now we've got to do it. Step 1 says simplify the left side completely. Well, over here on the left-hand side, we've got some common terms. We've got a 3k and a negative 5k, and we have a plus 5 and a plus 10. So we're going to put those together, combining those into smaller packages. 3k and a negative 5k is a negative 2k. And then the positive 5 and the positive 10, that's a positive 15. And that's going to be equal to our k plus 21. Now the problem looks like everything we've seen the last couple. We've got a variable on the left-hand side and on the right. So we've got to invoke the next step in our recipe there. What do we do if we have a variable on the right? We've got to get rid of it. I have 1k on the right-hand side. How am I going to remove it? You guessed it, that's a minus k. I'm going to put it over here with the k's that are on that side. What that will do on the right is get the k's to cancel out. K minus k is 0. That's what we want to have happen. On the right-hand side, all I have is 21. What's on the left-hand side? Negative 2k and negative, how many k is that? 1. Remember, if there's no number, we understand it to be 1. Negative 2k, negative 1k is a total of negative 3k plus 15. Now we're to the next to last step in our recipe, isolating that variable. We've got 2 steps. We've got a plus 15, we're going to minus 15 on both sides. That's going to leave me with negative 3k equals 6. Negative 3k equals 6. I'm going to rewrite that right up here. Negative 3k equals 6. So I'm running out of space. So now we're going to divide both sides by negative 3. And that will divide out the negative 3 that's sitting there with the k and leave me with just k equals 6 divided by negative 3, negative 2. Final answer, variable equals a number. We're done. Okay, let's keep ramping up the challenge just a little bit more. Taking a look at the problem here, what do we see? Our first step in our recipe says we want to simplify the left side completely. This is something we haven't seen today in our module yet, but you have seen it. I promise you, you saw this in 8th grade. So what do we do? A number outside of parentheses, that should set off flashing bells that say distribute, distribute, distribute. So let's do that right now. We're going to take the positive 3 that's outside times the positive 2w on the inside. That's going to be 6w. And then we're going to take the 3 and multiply it times the negative 4. How do I know it's a negative 4? Because it says it. It's minus 4. Minus 4 and negative 4 mean the same thing. All right. So 3 times negative 4 is going to be a negative 12. And that's going to be equal to 18, just hanging out over there waiting for everything on the left side to get straightened out. We are now to what step? We don't have an x term on the right. We don't have a variable over there. So we're just ready to isolate the variable. So that's an easy, quick two-step process. Plus 12 because we had a minus 12. So we're going to go plus 12 on both sides. That's going to leave us with 6w equal to 18 plus 12. That's going to be 30. And to finish this problem, we're simply going to divide both sides by 6. And that'll leave me with w equal to 5. Variable equal to a number. We're done. So there are several examples we have gone through now where we have followed this recipe. Simplify the left side completely, simplify the right side completely. Do you have a variable on the right-hand side? Get rid of it using addition or subtraction. Then isolate the variable. That's going to be usually a two-step process where you add or subtract a number and then multiply or divide by a number. That will take you to your final answer where you just have a variable equal to a number. What we will do next is go ahead and go to the practice video now, and we'll work some of these where the same way we did in Module 1, pause, work your problem, resume the video, and compare what your work looked like to the way we did it on screen. Thanks for watching on this module, and we'll see you soon. Bye-bye.